Good afternoon, everyone. Today's lesson is going to be about annuities, and I'll explain the timeline diagram thing in a moment. An annuity is basically making regular payments. So when we've done compound interest and simple interest, we talked about an initial investment, the principal amount, and that was pretty much it. You put money in once, and you kind of wait and see what happens. Most people don't save money that way, right? You are more likely to make little installments over a period of time. So an annuity is a particular situation where you're making a series of equal payments or deposit at regular intervals over a fixed period of time. Okay, so you're just making the same amount over and over again at regular intervals. Okay, so to show how this works, we're going to do this with an example. We'll get into it right away. So here's our example. At the end of every month, Aubrey deposits $50 into a GIC that earns 4.8% compounded monthly. How much will it be worth at the end of 4 months, 4 years, and 4 decades? Okay, so we're going to look at how that goes. Okay, and in the process, we're going to kind of build up to a formula and things as we go here. We'll start with the 4 months. So to show what's going on, we're going to create what's called a timeline diagram that keeps track of all these installments that are going in to the bank. Okay, so I just drawn a little number line. Okay, and it's 4 months, so I'm going to label this 0, 1, 2, 3, and 4. Okay, it said we were making the payments at the end of the month. Okay, so I'm just going to put at the end of each of these months, okay, I'm going to put down the next payment, right? So I had $50 at the end of month 1, $50 at the end of month 2, and so on. So there's my 4 payments. Okay, so now what I'm going to do is think about what's going to happen to the interest for each of these payments. So if I check my account at the end of the 4th month, what's going to happen? So for that first payment, for the 50 here, it went in right at the end of the 4th month. So it hasn't had any time to earn interest. So that's just going to be $50. Okay, for my next payment, okay, this will have earned interest. So it's 50. Okay, and now we're using the formula from yesterday from compound interest. So just up here above, I'm going to kind of work through a little bit of that just so you can, as a refresher, and so you can see the pattern that's going to develop here. Okay, so in the compound interest formula, right, my principal amount is the $50. Okay, A would be what it's worth at the end of the month, so I don't know what that is. Okay, I is the interest rate per compounding period, so that's 0.048, right? The 4.8% as a decimal, okay, divided by 12, so 0.004. Okay, and for n, remember, it's the number of compounds. This is literally there for just 1 month, so it's going to be 1. Okay, so right, our formula is A equals P 1 plus I to the n. So those can be 50. 1 plus 0.004 is 1.004, and that's the power of 1. Okay, so for this payment, it's going to be 50 times 1.004, which we can work out in a moment. For the next payment, okay, at the end of the 4 months, it will have been sitting in the bank for 2 months. So the calculation will look pretty much exactly the same as the last one, except it's just going to have a squared there, right? Because it's been in there for 2 months. Okay, the only thing that would change would be the value of n in that formula. Okay, for our last payment, it's been sitting in the bank for 3 months. So that's 50, 1.004 to the power of 3. Okay, so now I just have to go through each one of those and figure out how much it's actually worth. Okay, and then go from there. So we have 50. Okay, 50 times. Okay, the next one is $50.20. Okay, the next one is $50.40. There are some more decimals, but it rounds off to 40 cents. And for the last one, it's $50.60. Okay, and again, there are more decimal places there. It's like 50.6024, but it still doesn't round off to an extra penny yet. Okay, so totaling that up, okay, from our cents, we've got what, $1.20 there. So this is going to be $201.20. Okay, and there's a total worth at the end of 4 months. Okay, great. So that was for 4 months. Okay, our next level up here for part B was do this for 4 years. Now, that would be a pretty big diagram. Okay, remember we were talking about 10 there. This is where we go back to the formula for a moment. Okay, what's the total number of compounds in 4 years? Well, it's 4 years, and I'll bring this in every month. So that is 48 of those. Okay, however, we don't really need to go through and do that individually, right? Or I don't think we'd want to, right? We wouldn't want to make a timeline diagram for 40 payments and see what happens. Okay. But if we start writing down the list, right, what's going to happen here? To get this total, right, it would end up being the same thing. The very last payment, right, the 48th payment would just be sitting there. It would be 50. Okay. The 47th payment would be 50 times 1.004 to the power of 1. Okay. The 46th payment would be the same thing to the power of 2. Okay, and so on until we got down to the very first payment, which would be sitting there for 47 months. So that's 1.004 to the 47. Okay. Hopefully this looks a little bit familiar. Okay, right? This is a geometric series, right? I'm going from term to term by just multiplying by another 1.004 over and over again. Okay, so I could actually solve this problem using the formula for the sum of a geometric series. So let's review what that looks like, right? Sn equals, okay, that's A times, I'll make sure I get it right in this note, right? R to the n, subtract 1 over r minus 1. Okay, what's my value of A? My value of A is 50. Okay, what's my value of R? That's the 1.004. Okay, n is the total number of terms, and that's 48. Okay, there are 48 installments here. Okay, minus 1 over my R, again, is that bracket, 1.004 minus 1. Okay, and now it's just a matter of running this through our calculator. So okay, so we got $2,640.08. As a quick check to see if that's actually reasonable, I'm just going to multiply 50 by 48 on my calculator, which is $2,400. Okay, so that means I've made about $240 in interest there. Okay, so there we go. So to do an annuity, or to get the total value of an annuity, I can basically just run it through the sum of a geometric series. Okay, so before we do 4 decades, we're just going to do a little sidebar here. Okay, because this relied on compound interest formula to start us off, we're going to put the two of those things together now. Okay, so the annuity formula, it looks something like this. I have FV, which is my future value, equals PMT, my payment, times. Okay, what's my R, right? What was I multiplying by? That was originally 1 plus I in the compound interest formula. It's to the power of n minus 1. Okay, on the bottom, so don't write this down just yet. Okay, right? Again, my R is 1 plus I, take away 1. Okay, but if I tidy that up, those 1's will cancel out. Okay, so my denominator is really going to be just I. Okay, my interest rate per compounding period. Okay, and there you go. That is your annuity formula. Okay, and again, we're just going to write down what those things are. So that's the formula where FV stands for the future value, right? How much it's worth at the end. Okay, PMT is the regular payment you're making. Okay, I is the interest rate per compounding period. Okay, and N is the number of compounds, or in this case, it's the same as the number of payments that you're making. Okay. As a little aside, I think the textbook uses something slightly different than what I've written here. Like the structure is the same, it just uses different letters. So I think the textbook is FV equals capital R, okay, 1 plus I to the n minus 1, okay, over I. Okay, or I've seen the formula using the A from the compound interest formula, the same idea, right? The final amount of my annuity is equal to my regular payment, and then times the rest. Okay, they mean the same thing. I kind of like the one that I've written in green, simply because it reminds me what piece is what, right? PMT stands for payment. That's pretty straightforward. FE is future value. Okay, but you might see that other formula in the textbook. Okay. So to calculate the final amount or the future value for the 4 decades, okay, we'll do that now. So for 4 decades, actually, we'll just go through the whole process here. So future value, payments, I, and number of payments. Okay. Okay, so future value is what we're looking for. Our payment was $50. The interest rate, again, it's still the same thing, but I'll write it out again. It's 0.048 divided by 12, which is 0.004. Okay, and my number of payments, well, it's 4 decades now, so that's 4 per year times 10 years times 12 per year. So that would be 480 payments in total of $50. Okay, so now let's go to our formula. Okay, our future value equals our payments, which is 50 times 1.004 to the power of 480 minus 1, okay, divided by 0.004. And now it's just a matter of running that through your calculator. Okay, if you can do it in one step, which is what I'm going to do on the side here, that's great. Okay, if you can't, just order of operations, right? You have to do this part first with the exponent, then subtract 1, then multiply by 50, and finally divide by 0.004. So when we ran that through, okay, I got $72,436.07, rounding it off. So that's how much that's worth. So again, it's a little check to make sure this seems reasonable. I'm going to take the 50 and multiply that by 480 and see what I get. Okay. Now, this is where it's a little interesting. When I did 50 times 480, I only got 24,000. Okay. So when we have gone way, way, way out, we have more earned an awful lot of interest on this investment. Okay. Which in the big picture is one of the key things about investing. The earlier you can start saving money for something and get it into something that earns a decent amount of interest, that's when you really make money in the long run. Okay. Like you've basically, earned double the interest on top of what you've actually paid in yourself at this point. Okay. So I'm just going to do one more example, kind of going in the other direction. So Aiden plans to buy an expensive car 10 years from now. Try to make this a little bit bigger for you. Okay, he estimates he will need to save $20,000 for a down payment on this car. Okay, he's going to make monthly deposits into a high interest savings account that earns 3.5% interest, compounded monthly. How much will Aiden need to deposit each month? Okay, so you've got a goal of $20,000. How much are you going to have to put in every month to make this happen? So we'll write out our variables. Okay, our future value, well, that's our target, so that's $20,000. Okay, our payments is what we're looking for. Okay, our interest rate, so this is going to be 0.035. Okay, and it's monthly again, so we're going to divide that by 12. Okay, now this one does not work out quite so nicely. So we have 0.0029166. Okay. So I was mentioning this yesterday, I think. When you have a fraction, right, that doesn't reduce nicely like that, that's a long decimal, you should keep as many decimal places as possible in your calculations. Okay, or if you get the fraction, like my calculator showed me the fraction first, it was 7 out of 2,400. But yeah, you use a lot of decimal places in your calculations and then just round at the end. Okay, so I wrote down all 10 digits from my calculator. I'm going to need those 10 digits to make sure this is actually accurate. Okay, finally for N, this is 10 years, and it's 12 times per year, so it's going to be 120. Okay, so now let's start filling in the formula and see what we can do. Okay, our future value is $20,000, so that goes in where FV was. Okay, we're looking for our payment, PMT. Okay, my interest rate, so 1.002916666 to the power of 120 minus 1 all over 0.002916666. Okay, so the way I'm going to approach this, there's a couple ways you could do it. Okay, I'm going to tidy up on the right-hand side first. I'm going to run this part through my calculator and divide it by there, so I just have a coefficient to go with my payment. Okay, so when I run that side, I'm going to have PMT. And what do we got here? So Okay, I got 143.4325.045. Okay, and then last step would be to do 20,000 divided by that number. Okay, so 20,000 over 143 point dot 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 equals my payment. So I got $139.44. Okay, so that is how much money Aiden would have to put away per month for 10 years to have $20,000 saved. Okay, so there's the basics of annuities. Okay, right, for very small ones, you could do with a timeline diagram, but we showed how that leads to a formula. Okay, and so you can use this annuity formula when you have regular payments. Okay, so for practice work, okay, starting on page 511, there's 5 questions to practice solving with annuities. Again, tomorrow we're going to talk more about annuities, but use them for debts. Okay, what happens if when you're owing money? Okay, it's because there's a little tweak you have to make to the formula to do that. All right. So thank you very much for watching, and I will see you tomorrow.